Thanks for being here, everybody. So what we're going to be doing today, well, first of all, my name is Jose Escobar, and I'll be leading the training today. And what we're going to be covering is irrigation. So we're going to be covering the focus on this is going to be it's fairly basic. We're going to be covering water systems, valve installation, recipe settings, dosage percentages. So we're going to talk about where those come from, some tank management, start programs, and substrate start programs. So that's going to be the focus on it. And so we've got kind of in sort of a logical order in which we're going to approach this, but there are going to be times where, say, I might be jumping back and forth between different pages just because, one might relate to the other. So, or, might circle back around to it as we kind of progress. First, I hope you guys can all see my screen. Yeah.
Yes.
Yeah.
Okay, great. So we're gonna start with navigating to our water section. So if you have some experience already with Priva, you might already know these pages. If not, no problem. You can actually just navigate it for our water through the water section here. Where we're gonna start. We're going to start with our water systems. Actually, where we're going to start is the installation of how we have to link your valves and your main lines. Because with water management and irrigation control, we have multiple things, right? We always have a water system. We always have a main line. Sometimes the main line is an actual, like, let's say, physical mainline valve that we open. Sometimes it doesn't exist, but either way, we still need to link a mainline valve to water system, and then you link your irrigation valves to that main line, right, which is tied to your water system. So the first thing now, whenever you make these links here, typically they don't change. For at the least the water system to main, usually this doesn't change. It's once we link it, we kind of leave it alone.
Jose,
Normally,
real quick, I just
yeah.
wanted to interject and just
Yeah, no
say
problem.
if there's any questions, we really want to encourage people to chime in and ask questions freely. I know not everybody was able to get onto the first live training, so we're hoping that by keeping it a little bit smaller, we can engage a little bit more. So everybody's encouraged to speak up if you have questions during the training, and also if you want to just put them into the chat, we can address those later also. So thank you.
Yeah, no problem. Thanks.
Excuse 1 minute, please.
Yeah.
My one question is this meeting being recorded?
Yes, and it'll be available next week on Priva Academy.
Okay, thank you very much.
Okay. So, excuse me. Typically on most installations, we have something like this where we have a main line and you have a water system. A lot of times it's just one main per one water system, and we number it in a way to where it makes sense, right? But every installation is different. So sometimes you have multiple main lines connected to a single water system. So it really just depends on your installation. But again, usually once either Priva or your dealer helps you with these links, you really don't have to remake them again. These are physical things, right? Physical installation properties that just don't necessarily change. Then you have your valves to main. So if we click on this box here, here's how these valves are linked. And just sorry to back up a second. This is a virtual environment, so this is a simulator. This is not a working environment, but it does resemble that of what you guys probably already see right on your day-to-day when you're using Priva Office. So this is just a simulated environment. So what we have in this environment here is, excuse me. So we have our mains, our valves 1 through 5 connected to main 1. And what we saw on the previous page is that main 1 is connected to water system 1, right? So that's kind of how we have to think of it, is that those valves are connected to water system 1. So whenever the valves 1 through 5 want to irrigate, they may or may not open the mainline valve if there's a physical valve that we open. But it will definitely send a request to the water system 1 so it can run, right? And run any recipe that's tied to that water system. And then for our demo here, main 2 is the rest of the valves 6 through 27. So that's just a second water system. And then main 3 for us is a UV disinfection system, so that there's no irrigation valve tied when we have one of those types of water systems that's linked to like a tank and a fill valve, right, where it's just treating treated water, sending it to a treated water tank. Okay. So again, these usually don't change. Sometimes what does change is these links here. So maybe if you have multiple main lines for one water system, maybe during one period you'll have the valves using main 1, and then through another maybe crop phase or something you might have valves linked to main 2 now, right? So we'll start with water systems. So that's page I-430, and to get there you can just go to water system, and it's actually this this tab here, reset water system. What you have here is, you'll notice it's page I-430, and you have different tabs here. So there's like a logical order in which they do this. So if I click on settings here, that's I-430.1, 0.2, right? I'll be going, I won't be going through every single one of those, every single line. I'm just going to cover the ones that I think that are really important, that people ask a lot of questions of. But feel free, if you do have any questions over a specific line, you can just let me know. So on this page on I-430, this is the page you're going to go to if your water system goes into error to reset it. So it could be for any number of reasons. And if you kind of hover over this, it'll kind of give you a little list there. But if you right click and hit advanced control, that'll give you more of a status of what could be the the statuses of the water system. So you can right click it and you can store the status. So in the future, if you ever wanted to know what happened during the water system, like if it alarmed or something, if you're not storing the status, and you're not going to have the data to go back and maybe figure out, okay, at what times did we have maybe some sort of error or something like that. So you can store these values, and if you graph them, it's just going to be a horizontal line, but it'll give you a number so you can see, okay, what was it, right? The most common ones is going to probably be just an error or an operation. So 3 being operation, 4 meaning some error for some reason. What you should also know is the limitations here. So there's a number of limitations that can happen if there's an error with your water system. The most common one is, if it fails, will be limitation number 7, which is dosage. So that's if EC or pH control fail, for whatever reason. And another one that happens that I feel like I get a lot of questions of is 14, which is external weight. So what is external weight? That depends on the water system that you have. So if you have a Priva water system, depending on which one you have, say you have a NutriFlex with a mixing tank, there is a certain number of protections that we have to stop the pump from running if certain things happen, right? So the first thing is if the mixing tank runs empty. If the overload, so there's a overload protection for the motor, if that gets tripped, or if there's a high temperature switch on the pump. So those 3 things are essentially connected all together, and they will send a signal to Priva, and we will interpret that as an external weight. That is not a software or controls thing. That's an actual physical thing that happened, right? So either the mixing tank went dry, so you got to find out, okay, why did the mixing tank go dry? Let's say there's a fill pump filling that mixing tank, maybe something's wrong with that, or the supply line, something's going on with that. The overload, so the overload just needs to be reset inside a Priva water system panel. There will be an overload with a dial on it that needs to be reset, or it could be a temperature switch. So could be that the water temperature was measured too high. Maybe it was deadheading or something, so the water basically just wasn't moving. Now that one is a self-resetting switch. You can't do anything about that. You just have to wait for the switch to reset itself. So if you see that external weight, again, it is not a software thing. It's a mechanical or electrical thing that's going on, that we receive a signal that's saying, hey, there's an alarm. Okay. And now set weight, that's done if you're doing any kind of maintenance. So if you're, let's say, calibrating pH sensors, cleaning out EC sensors, any kind of maintenance you're doing, and you do not want the water system to run, then you would just set it to weight here. So by setting this to weight here, if any valves get a start signal, they basically are not allowed to run, right? So you have to wait until you take this off weight, and then the valves can start to irrigate. And if it goes into failure, you would just reset this here, and it'll attempt to start the water system again. Now, if it failed for, like, let's say EC or pH issues, you weren't hitting set point, or maybe flow or something, it might alarm again. You have to determine, okay, what's causing that alarm, right? So if it keeps on alarming. Okay, so real quick, we'll talk about these important settings here. So one of the most important settings on here is it's kind of one of those questions where if you want to run multiple valves at a time, you've got to look at see how this is set. Now there is actually dealer settings that we have that you don't have access to that your dealer or Priva can change to limit the number of valves that can run at a time. So that could also be a reason why. But if you want to run multiple valves here, usually the way you can set this table up is as radiation increases, you can allow more and more valves to open because, you know, with an increase in radiation, you can expect maybe more transpiration of the crop, and maybe you're going to have more of a demand, right? But I would say that most people don't actually use this table that way. They just sort of set it like, let's say you want 4 at a time. They just set it like that, right? So you just, hey, it doesn't matter. It's not radiation dependent. It's just, hey, I just want to be able to irrigate 4 valves at a time if I want to, right? So you can set it this way. So if for whatever reason it's not, then this could be one of the settings that's limiting you from irrigating multiple at a time. And then the next one is recipe. So basically the way that this setting works is going to determine. Now this really is if you are irrigating multiple valves at a time, and maybe even because it's possible to irrigate multiple valves that are tied to different valve groups, different sharp patterns, which we'll talk about that later. But it'll take priority. It'll take a recipe priority first before the valve group. So that way it prevents any kind of rinsing, too much rinsing. If you even have rinse valves, some installations don't have rinse valves, but if you do, and you want to prevent it from doing too many rinses after irrigation, after recipe changes, then you might want to use this setting here. Otherwise, if you can choose valve group, and it will basically determine which valve group goes first as a priority, not necessarily recipes. And the next setting here is flow margin and monitoring. So this right here is a setting that will actually alarm your water system. It'll stop the water system if your flow deviates, right? Or if there's no flow. So this is a percentage. So that's 25% above or below your, and this is just a default setting, by the way. So if your flow is 25% higher or lower, then it'll stop the water system. It'll alarm. You have to switch this on to yes in order for that to happen. Okay, but there's a delay, so you can have a delay of 30. This is default 30 seconds or more if you want. And if you hit F1, by the way, maybe a lot of you might already know this, but if you hit F1, it actually brings up the manual to whatever page you're actually in. So it'll kind of give you like a little overview of it, so you can kind of see here visually what's going on, right? So it's really common for when a water system first starts, you know, that maybe the main line is maybe has some leaks or something, so it's not under pressure. It's kind of filling back up with water, so you might have a very large flow once the irrigation first starts. But then after the line's been pressurized, then the irrigation will start to kind of match the calculated flow. So this kind of how it is. So in this example, it's plus or minus 15%. So if you're, you know, outside of the alarm delay period, then it'll stop the water system.
Jose, we have a question asking where the flow is measured. Is it measured at the pump?
Downstream of the pump, yeah. There's usually a flow sensor downstream, yeah, of the water system.
Okay, thank
you. Yeah. And the actual representation of where it's at is on M430, which we'll get to that as well too. So for the rest of these lines, it's very uncommon for this to be, because you can actually start the water system manually without any irrigation valves, but we rarely ever have a reason to do that unless it's a acid dosing, just like let's say a recirc loop that's just running a recipe that's just injecting acid. But usually, even in those cases, we don't use this override here because we just link it to a tank, which we'll talk about tank management later. Of just like a fill valve, say, hey, okay, we got a certain amount of water in a dirty tank. We're gonna treat that water and put it into another tank, and so then the water system is released for acid injection in that case. So it's extremely uncommon to use this here. And then then we'll look at our overview. So you're over now. Here's where you would actually see the flow. Here's your in this case. Well, the water system 1 and 2 aren't running. So water system 30 on this simulated environment is just our UV disinfection unit. So it will be measuring your dosage here, and it will tell you what the deviation is. So if there's a deviation in flow, it'll give you that plus or minus, right? Some information of what this does. Now, this is just an overview page. So you'll see at the top here that it says M430, not I430. So M like measurement. So this is just a measurement or calculations page. Anytime you're at an M page, a page that starts with an M, that means it's just measurements, calculations. You'll see that all these values are just gray. So you can't actually change any of this. It's not like a set point or anything. It's just giving you some information. So just giving me some information. So right now, water systems are on rest. The last recipe they used was recipe 1. No measurements for EC and pH, so these are just not real sensors. So to give you just an overview of what our UV system is doing, if our valve groups are running, so if we had our valve groups that are running, they would be actively irrigating, rinse valves, and then what our tanks are doing. So we have 4 tanks in this particular demo, and gives you our water level. So, and again, this is just specific to your installation. So you may not have you may have some or some of this, maybe not all of it. So for instance, everyone for the most part, if you have a water system software that we're doing EC pH control, you'll have for sure this, but you may not have EC supply. So EC supply is basically a mixing valve with an EC sensor upstream of the water system. And so that is controlling the EC before it hits your water system. And then your dosing channels will basically make up the rest, right? So in those types of installations where we are blending, let's say RO or, so whatever your source water is with, let's say, a treated tank that's been treated and disinfected with like a UV system or something like that, and you're reusing the fertilizer. So you're bringing that you're targeting a certain EC before it even gets to the water system, and the water system just makes up the rest of it. And then temperature control, we can also control the temperature coming into the water system as well too. Questions so far? Hope that makes sense. So, okay. So that's your basic water system overview. So we'll talk about next your valve installation page. So the valve installation pages are really important because those are going to determine what your flow rate is, right? What your calculated flow rate and what your measured flow rate is too. So we'll start with, again, to navigate there, we can go to water, irrigation, and valve settings. So we got our valve settings, start, expected, installation, control. So we have all these tabs we can choose from. I'll start with first the installation. I think that's probably what we need to make sure is correct. Okay. So you basically need to count up the number of units. It could be anything. It could be the emitters. It could be the actual like drippers, the number of pots you have, as long as it's consistent, right? So you have to count up the number of units and what the capacity is per each one. And that's in liters per hour. So when this valve runs, you basically just multiply these. So it's 1,000 times 2, so that's 2,000 liters an hour, and 1,000 liters an hour is 1 cubic meter an hour. So we know that when this valve runs, our expected flow rate, our calculated flow rate, is going to be 2 cubic meters, right? So that's what the flow sensor should measure is 2 cubic meters. Now the area. You want to make sure you put that in just for registration purposes for reporting. So it's not factored into the flow, but it will give you some more accurate data if you want to know how much you're irrigating, per cubic meter, for example. Protection. So the protection is if you want to stop a valve, if there's a flow deviation. So this ties in with the water system alarming on like 430.1. So if I set this to yes, what happens is the water system will alarm, right, for a deviation in flow, and the valve will actually stop as well too. So you have to actually clear that alarm for the valve first. If you go to and I'll touch on this start here, but you actually have to have it continue. So it's almost like an acknowledgement of, hey, there's an issue with the valve. So you have to allow it to continue, because if, let's say you just reset the water system, it's going to basically skip that valve. And it's going to kind of go down the line of all the other valves, and it won't pick up on that valve again. You're going to have to select to continue, that you want to continue with the irrigation despite the deviation in flow. So it sort of makes you check the valve to what's going on with the installation. And that's if you have it set to yes. You could still alarm on the water system 9430.1 if there's a flow deviation. That's no problem. You can still alarm that way. The correction percentage, you can go minus or positive up to negative 100% or positive 100%. So what this does is it gives you an extra, like, let's say 20%, for example, extra runtime. So or quantity. So if you have, say, for instance, valve 1 and 2 that are connected to the same valve group, so they both start at the same time, then what they do is valve 1 and 2, they're going to run together, but valve 1 is going to get 20% more. So it's going to actually stay open longer, and it's going to get 20% more irrigation. So why would you do that? Maybe the crop is on valve 1 is slightly larger than the crop in valve 2, so maybe it just has more of a demand for water. Or the other way around, maybe it's a smaller crop, so you might want to, reduce take off 20% of the quantity and time. So that's how that setting works if you want to adjust the amount of time for that valve. Your drain percentage here, this line here, it's not a set point. This is just kind of what this is what the expected drain is of that valve. So when you've irrigated valve 1, you expect 20% drain. This is just a standard number for standard irrigation valves, ebb and flood type valves. It's actually 60% is the expected drain, but you can play around with this number here, but it's not a set point. You can control drain, but that's using the substrate start strategies, which is something we'll briefly touch on later on in today's training. And in the above measuring box, that's yes, no. So basically what that does is if you have a measuring box in that zone, then you can actually turn off the fan. I guess this would only be useful maybe if you have like overhead, like sprinkler irrigation, maybe if you want to turn off the fan during an irrigation, but that's an option here. So that's what this line does. Okay. So control page. Now this page here will allow you to start multiple valves at the same time. But this isn't the only place. There's another place where we can control the valves that open at the same time, which we will talk about later. That's in your valve group settings. So there's two possibilities. So the first, so obviously the first column here, that's just your valve numbering. This, oh, sorry, I thought I heard something. The sequence, that's just kind of the order that they're going to open. So if let's just assume that valve 1 through 9, for example, they all get the same start, but it's only one valve at a time. Well, it would go in order. So it would start with 1, 2, 3, 4, all the way to 9, for instance. If I was to reverse the order and start with 1 here and count it up to 9, then 9 will take the priority. So 9 will start first, then 8, 7, 6, all the way down to 1. And maybe you want to do that because maybe physically 9 is maybe a valve that's closer, so you want to start that one first. Physically on the block or something where they're at, or for any number of reasons you want to actually prioritize a certain valve to get irrigated first. You can do that with this sequence number. Now, the number together one, this is the one where if you want, they have to match. Now, again, there's another place where you can control this, but if you want to, let's say, have valves 1 and 2 run at the same time, you would have to do something like this, where valves 1 and 2, they have to have the same matching number. And then let's say valves 3 and 4, you wanted those to run at the same time, you can do something like that. So valves 1 and 2 run at the same time, then valve 3 and 4 run at the same time. Another option too is if you do something like maybe something like this, where they all have the same number, but what's going to happen is they still valves 1 and 2 are going to run together, and then valves 3 and 4 are going to run together. So this number together here, it's got to be greater than or equal to the number of valves you actually want to run together. So if I do something like this, then valve 1, 2, and 3 is going to run together, and then once that's done, then valve 4 is going to run. Right. So that's how that works. But again, there's another way of doing it. So this is not the only way. And not together, that's if you do not want them to run together. So for sure, for whatever reason, I mean, of course, if they are on different recipes, they're never going to run together anyway, if they have different recipes. But let's just say they do have the same recipe, and there's nothing limiting them from running together at the same time, but you wanted them to never run together, then you have to do this as well too. So you have to make a match. Let's say you never wanted 1 and 3 to run together for whatever reason, in some installation limitation, then you would just have to make sure that they have the same number, and that will prevent them from ever running at the same time. So in this case, you would, have valves 1 and valves 1 and 2. Well, yeah, I guess valves 1 and 2. If you do something like this here, then it will actually be valves 1 and 3, for instance, run together. So it just depends on how you set all this up. But basically, this not together here is as long as they have the same number, the valves will not irrigate. The close time, you have you can go plus or minus 9 seconds. All this does really is just if you put a positive number in here, like let's say 2 seconds, what that does is it makes sure that the valve is fully closed before the next one opens. Now, if you do a negative in here, like negative 2 seconds, for example, what that does is it ensures that the next irrigation valve is open before this one fully closes. Okay, and that could be the reason they do that is just to limit any kind of water hammering, or to help prevent any kind of water hammering, or to any kind of variances in pressure. So that's why they do that. If your valves have a runtime, and if you want to open the next valve before you shut the other one. Okay. All right, and now we'll talk about our basic valve settings. So for your valve settings here, if you put in, you could just put in a quantity, like let's say it'll automatically update these quantities, and of course this quantity per cubic meter depends on what you put in. If you put in, I mean, I've seen some installations where there's just 0 in here, so nobody fills in any kind of area for the valve. But as long as you put in some sort of area for here, it'll basically calculate what your expected quantity is, per cubic meter, or sorry, per square meter. So now one thing to keep in mind here is that you have quantity and you have time, right? So the irrigation is based on whichever comes first. So if you want 50 milliliters, if that's your your target, once the flow meter has counted that, hey, every emitter has been irrigated 50 milliliters, then it'll stop. It won't hit the 5-minute timer, right? But if you, let's say you put in a large quantity here, I don't know, let's say like 200 mils per unit, but you put in a very short time in here, like 30 seconds, for example, maybe by accident, the flow meter might not count this, right? It's depending on the flow rate of the capacity, your emitters. So it may never actually count this quantity. It'll just close after 30 seconds. So it's whichever comes first. Okay, so you always want to make sure that you might have to calculate how long it's going to take, okay, to irrigate a certain amount, and then put in roughly that time as a protection. So maybe there is a small issue with the flow meter. Maybe you're not alarming. So I-430.1, you're not going to alarm. So maybe there's a problem with flow. But your water system will stop, right? So maybe that's going to be like a protection of, okay, just to prevent you from over irrigating. Let's say there's an issue with your flow meter and it's not counting flow correctly. So it'll still stop after a certain amount of time. Okay. And
Jose, sorry to interrupt you. We had a question come through about just the earlier discussion you were having. They were asking, so with negative, you will have 2 valves open for a short period of time on the close time?
yes.
Okay, thank you for clarifying.
Yeah, when it's negative, yeah. So before the valve that's irrigating closes, the other one will be fully open. Yes.
Okay, thank you.
Yeah. Okay. And yeah, so quantity and time, so whichever comes first, and your recipe number. So it'll run, in this case, recipe 1. Now there are similar to the control page here, where we can start, multiple valves at a time. You can also irrigate a different quantity and time based on your valve group settings, and again, we'll talk about the valve group settings as well too. So these settings are used if you choose to at the valve group settings. So we'll talk about that. But if you want to do a manual start here, then manual starts on I-412 here will follow this setting, right? So it will not. So you could have different settings at the valve group level, right? When you're setting up your automatic start strategy. But if you do a manual start, it's going to be this amount. So this quantity or time. Okay, if you do a manual start here. Okay. Couple of options that you have here on your valve start stop reset page. So you can start the valve manually. You could put it to wait if maybe you're doing maintenance on it or something. Continue if it goes into alarm and you clear the alarm. So if there is a flow if there's a flow alarm and you have the protection set to yes on that valve, then you would have to hit continue in order to allow it to continue on with the irrigation. And then stop. So stop, you can stop the valve for whatever reason, whether it's a manual start here or whether it's an automatic start from your valve group or start program. You can come in here and immediately stop it for whatever reason. Okay. Okay, so that was it for valves. And one other thing I'll mention too is Start Valve Wizard. I just like to let people know about this because it's a nice little tool if you are making changes to these valve settings. So like for instance, if I wanted to change all of these to like 100 milliliters or whatever, then I have to go each one at a time, and that could take a long time, especially if you have a lot of valves. So I can actually use a Start Valve Wizard to do this all at once. So I can make a setting change only. I can set and start a valve, or just start valves or stop valves, right? So same thing with stop valves. If you want to stop a bunch of valves, you can go through and stop one at a time. That can be time consuming if you have a lot of them that are active. So let's say I wanted to change to 150 milliliters per each one, and I'm going to do all valves. I can do that. Okay, so now if I go back to 11, there it is. So quick and easy change on all the valves, and instead of having to do one at a time, so it makes it easier. Or if you wanted to start, valves, just blocks of valves and all that, so you can do a lot of different things with this here. Okay, and then lastly, M411 is just your overview. If you had any active valves, it would show up here. Right now we don't have anything active, but it'll tell you, which valve it is, the quantity as it's irrigating, and the time as it's sort of counting down, right? The quantity and time for whatever its target is. At the moment, nothing is actually irrigating. Okay. So I think we can talk about our recipe settings now. So with recipe settings, this one is really, really important, and probably where I've seen maybe the most errors with this, where maybe there's some confusion as to how this works. Actually, first of all, before I talk about this, I should mention about your pH probes and your EC sensors. Oops. So your EC sensors would have been calibrated, when you first got your system commissioned. They do not need to be recalibrated. They just need to be cleaned, right? So your EC sensors should be maintained and cleaned. It really depends on what you're growing with, what your fertilizers are, but I would say most people that I talk to, probably at least maybe once a month or once every couple of months, they'll actually clean them out. So you just use a really soft brush and you clean out the EC sensors. Now your pH sensors, those should be calibrated pretty often. So some growers do it every 2 weeks, some do it every month. I would say It really just, again, depends on what you're using, what you're growing with, but you shouldn't really see a variance in your pH measurements very much. If you do, then it could be something going on with your pH probes, especially if they start to drift away from each other, because there's two different EC sensors and two pH one that they're checking against each other. So if you start to see that they drift apart pretty quickly, then you might have an issue with them. But so this page here, I-4032, is where you would calibrate your pH probes. You can, I would suggest when you're doing this, you can hit F1 and go through the manual to do it. But I will tell you that, first of all, you always start with 7. So as this calibration value here, you're always going to start with 7. As soon as I put that 7 in there, I'm going to get another line that pops up, right? And then I just hit yes whenever I'm ready to calibrate. It's really important that when you put it in the 7 pH solution, that you have to let it sit there for a couple of minutes, right? This page won't show you much. There's a tool that we can use that typically just Priva uses it, or maybe your dealer might know how to use it, where we can actually see the measurements kind of start to level out. So we usually wait on that, and I will say it's usually a couple of minutes. It's like 2 or 3 minutes before there's not as much fluctuation, and so that measurement levels out. When you move it to from 7 to 4, you should rinse your sensor. So you should just rinse it with distilled water, just rinse it, and then you put it in 4, and you have to wait a couple of minutes. So once you do this, and then you hit yes, I won't do it just because it's a simulator. When you hit yes, it'll go through its calibration. It'll say good 7, and it'll say good 7 if it worked. Now, when you change it to 4 and you calibrate that, again, you've got to wait a couple of minutes. I would wait at least maybe 4 or 5 minutes, because it does take a little bit of time for that measurement to sort of stabilize. If you do it too fast, it might go into error, and then you have to just start over again. So you have to start with 7 and then 4. So yeah, just keep that in mind of kind of regular maintenance on your EC sensors and regular calibration on your pH sensors. Because without good measurements, then we might struggle to keep up with the EC and pH, right? If we have bad sensors. Okay, so recipe settings. Recipe settings, really, really important, really crucial. I'll start with first of all, this gray value here. It's great because it's not something to change, right? This is a recipe for a water system, so it's tied to a water system. And for this demo, I believe the first 3 recipes are tied to water system 1. And then 4 through 6 are tied to water system 2, right? So if you say, for instance, you have valve number 1 that earlier on in this training, we saw that valve number 1 was linked to mainline 1, right? So it's linked to mainline or to water system 1. So if you want to run recipe 6 on valve number 1, you'll get an alarm. It won't let you. It'll actually say the verbiage on the alarm would be something like tied to wrong recipe, tied to wrong water system. Maybe some of you have seen that alarm. That's because he chose a recipe that was tied to a different water system that the valve is not linked to. So it won't allow you to run. Okay. So that's what that is here. Now your rinse group here, if they have a different number, so recipe 1 is tied to water system 1 with rinse group 1. And here's you got rinse group 2 and rinse group 3. So if the water system changes from recipe 1 to recipe 2, recipe 3, before every recipe change, it will do a rinse. If you have rinse valves, right? Not every installation has rinse valves, but if you do, it will do a rinse. And how long it does a rinse, it basically just depends on. Oh, nothing there. Yeah, just depends on how long you want it to rinse. 20 seconds, or usually we don't do it by quantity. It's just by time. Just rinse for 20 seconds or whatever the time is before it switches to the next recipe. Okay. Oops. Now, if they all have the same number, well then it's never going to rinse, right? Line number 2, selection 1. Typically this here, this is very specific installation here. This is if you have a selection valve, so that can select between tank A1 and A1 A2 or B1 B2. So that is like in this case here we have you can see we have an A tank, B, and an acid, right? So fertilizer, we only have two fertilizer valves basically in our software, right? But physically, you can double it up essentially if you have a selection valve that will change from, let's say selection 1 is always picking from A1, B1, and then selection 2, if you choose selection 2, then that actually whenever we run this recipe, it energizes the valve, switches position. Now you're pulling from A2, B2, right? So now you have basically an extra 2 dosing channels almost. You can think of it that way. Not a lot of installations have this, but that's essentially what it does. If you do not have this, it really doesn't matter what selection you use because it's not doing anything. So you can just leave it at selection 1. Now, if you leave it to no dosage, then that's just not going to control any dosage, right? You see these lines disappear, and there's no EC or pH control. It's just going to turn on the water system and not send out any fertilizer. Now, if you do this as well too, depending on how your system is set up, if you have an inline system, well, then it's still going to run the main system pump. But if you have a bypass system, then it's still gonna run the main system pump, right? But then the bypass pump that's just kind of getting water and recirculating back to the bypass line, it's just not going to run that injection unit, right? But it'll still run, if you want to irrigate a valve with no dosage, it'll still run the main water system pump on a bypass. Okay. All right. So now let's talk about these set points here. So in this case, we do have an EC supply. It actually looks like it's turned off. And again, I mentioned this earlier, but what an EC supply is you're looking for, it controls the mixing valve that is looking at an EC sensor upstream of the water system. So it's trying to achieve a certain EC before it even hits your injectors, right? In this case right now, yeah. So right now it's off, our EC supply is off. If you would normally turn it on, then you would have a set point. So I would, let's say I want 1 EC. So what that does is it'll try to measure 1 EC before it hits your water system, and then the water system will make it up. Or sorry, the injection units, the injector will make up the difference from 1 to 2. Not a lot of systems have it. Yeah, I mean, I've seen quite a bit, but I would say most of them don't have this. At least not the ones that I've seen. So for now, I'm going to turn this off for now, but that's basically how it works. And then you also have your 2 high and your 2 low alarms for your EC and pH settings. So I'll turn this off for now. So these 2 numbers here, this number, nutrient recipe, is probably the most important number on here. That's going to give you that you're basically telling the computer how, in a sense, how concentrated your fertilizers are, right? I'm going to pull up the manual for this. Now you do not have to do it this way. There's a lot of different ways of doing it, but I will go over this. Oops, that way, because I feel like a lot of people do actually do it this way. So what the computer wants you to do, or what we want you to do, is we want you to mix 100 milliliters of A and 100 milliliters of B. If you have multiple, so let's say you have C, D, or whatever, it's 100 milliliters of each. Okay, and you want to mix it with 10 liters of water. Okay, that ratio, 100 milliliters of A and B to 10 liters, is the same as that, liters per cubic meter, right? If you guys can see my mouse, it's the same ratio. Liters per cubic meter is the same ratio as 100 mils to 10 liters, just much smaller volume, right? So what you're saying is that if I do 100 mils of A and B, I'm going to get this result. This was the result of that's my nutrient recipe. So that's the result of that test. We call it a titration test. Okay. So after doing that, so now that's why the number 10 is in here, right? Because 10 liters per cubic meter is the same as 100 mils per A. Now, again, you don't have to do this way. If you did the mix with 200 milliliters of A and B, no problem. You can do that. You just have to tell the computer what you did. So now in here, you would just put 20, right? You're saying I did 200 milliliters of A and B. Okay, as long as you're consistent with it. So now, for the purpose of this is what we normally see is that. So if we do 10 liters per cubic meter, after doing this test here, theoretically, we should get 2.5 EC, right? That's what we should get based on the results of this test. And now if we scale it up to a full size irrigation system to liters per cubic meter, theoretically, we should get the same results. So when you have your desired here, depending on what your desire is, the computer will calculate an actual quantity. That's what this number is here. Okay, this calculated quantity is, it actually shows you in here as well, gives you like a, example of how it does it. But basically, you can think about it is if you do 10 liters per cube, you're going to hit 2.5 EC, right? That's what you should get. But you don't want that. You want 2 EC. So that's why the computer calculates, hey, I need to inject 8 liters per cubic meter to get to my desired 2.0 EC, right? Because if you do 10, you're going to get 2.5. Now, let's say you wanted 3 EC, then it should recalculate this number. The simulator sometimes takes a while to do it, but it'll recalculate this number to, like, let's say 12. Yeah, it should be 12. 12 liters per cubic meter, right? Because if you stick to 10, you're only going to get to 2.5, right? Theoretically, you're only going to get there. So to make up the difference, yeah, there you go. See, it adjusted the calculated quantity there. So it needs to do 12 liters per cubic meter in order for it to get to your set point of 3 EC. All right. I hope that's clear. Now, this number here, 12 liters per cubic meter, that is directly tied to the dosage percentage that you'll see on the M420. So M420. In fact, let me do this. Let me do this. So
Jose, I have a quick
yes.
question.
Mhm.
So every time you mix a new batch of fertilizer, do you have to do the titration test, or only if you change your recipe?
If you, well, not even if you change it. So like, let's say you I guess if you, let's say you have recipe 2 and it's the same exact tanks, right? A tank, B tank. The only difference is your desire is different. You don't need to do it again. The only time you need to do the titration is if you, let's say the concentration of your fertilizers change. So the way that you dilute your fertilizers changes. So now they're more or less, potent or less aggressive. Then yeah, you might need to remix it because you might get a different result in your nutrient recipe. Yeah, so it just depends. But you don't, if it's consistently the same A tank, B tank, you're consistently the same concentration. You only need to do it once, and you just need to set up the recipes the same. And if your desired are different, then it's just going to calculate the quantity here. But yeah, if you mix them at a different dilution ratio, now if you do this same test, maybe it turns out that it's more concentrated. Now you get 4 EC, right? So if you do that same test, now you get 4 EC, which is going to change this. The nice thing about the EC and pH control, it's a pretty good P&I control, and so it will correct and it will find its set point and it will try to reach that set point, right? So it's not just going to dose that and that's it. It will actually make corrections. And your dealer or Priva, we can put in some settings that will make that correction more or less aggressive, depending on your installation, depending on how aggressive it needs to be. But yeah, to answer your question, I guess if the concentration dilution ratios are different, and if ultimately you're going to get a different result on this nutrient recipe, then yes, you would need to do it again and see what that result is.
Thank you.
Yeah, no problem. So, let me explain this. The way that we set up dosing for EC and pH is on our EC sensors, or on EC control. We set it up as what we call a dosing control, dosing percentage. So what that means is that with this test here, we calculate what the dosing is going to be, and then we make corrections based on that. Okay. Now with acid, with this here, with your pH up or down, we set it. The type of control is just a correction, so it's purely reactive. Okay. So it's not just going to go to a certain dosing percentage. it's gonna wait until it's gonna see the measurement of your EC of your pH, and depending on how far you are, it's gonna inject less or more acid if it needs to. So you don't necessarily need to do the titration test with acid. However, I actually would recommend it. The way I have suggested other growers and I've helped other people do it is when they do this mix here, don't throw that mix away. So keep that 10-liter bucket with your 100 mils of A and B or whatever in there. Just start adding 10 milliliters of acid at a time. Just keep doing that until you get to your however many you needed to add to get to your set point, whatever that set point is, and then put that number in there. Again, you don't necessarily need to do it that way because the pH control is correction only. It's reactive. It is not based on a pre-calculation versus your EC control is, and I'll explain that. So that's on M420, right? Here's a page up here. That's your dosage overview, okay? This tells you like what the water system's doing, tells you what your calculated EC is basically whatever your set point is, right? So that's this desired. Same thing with pH here. So your calculated pH is this desired number here, okay? And then you got your calculated and measured flow. Now, you have to know your installation. You have to know the capacity of your dosing channels in order to know what your dosing percentage is, okay? For this demo, the settings are if we have a 300 liter per hour dosing channels. Okay, if you have a Priva water unit, we have 100 liter an hour channels, 300, 600, even 1,000 is our largest ones. So you have to know what's the maximum flow rate of fertilizer that the dosing channels can handle. That's going to give us our dosing percentage. Okay. Now, just by rule of just how a control system works and how, if you want to have good control, you don't want to be too far on the low end. So like 1-2% dosing, it's not going to be good accurate control, right? Versus even 90, like let's say 90-95% dosing, also not going to be good control. That means your dosing channels are working almost 100%. There's very small room for correction, right? So in fact, if you do this calculation, you get less than 1%, your dosing channels won't even work, which I have seen that before with systems with very low flow rates, dosing channels that are too large, and really concentrated fertilizers, where just a small injection causes a huge swing in EC, and we have to wait until it drops back down. And then once it's down below the set point, we do another small injection and a huge reaction. So you get this kind of, sawtooth type of graphs. So the way that we calculate the dosing here is related to this and your flow rate of the valve. So let's use valve 1. What did I say it was?
And Jose,
2 cubes. Yeah.
What strength of acid is the system set for? Can it handle any strength?
Depends on your acid channel. Yeah. So some of them have there's a 10% maximum. Some of them are 38% if you have like the 50 liter an hour dosing channel, and the actual valve and the check valve itself can handle higher concentration. So it depends. It varies on your installation, but the maximum is 38%.
Okay, but check with your particular system.
Yeah, check with your particular system and your particular valve and the venturi as well too. So yeah.
Thank you.
Just depends. Just depends. Yeah. So let's use valve number 1 for the example. So we know that when valve 1 runs, we have our flow rate is 2 cubic meters, right? 2 cubes an hour. So now I need 12 liters per cubic meter, right? Let me pull up my calculator here so we can do this together. So I need 12 liters per cubic meter, right? Easy, right? 24 liters per hour. So I need 24 liters per hour. Okay. I know that I have a 300 liter an hour dosing channel, right? So I can just divide that by 300, 0.08, right? So that's 0.08 times 100. That gives me my percent. So I'm at 8% dosing. Okay. So when this runs, valve number 1, right? I know that with valve number 1, I'm going to have 8% dosing. If I run 2 valves at a time, so let's say I run valve 2, it has the same flow rate. Well, then I can expect this to double, right? So now I have 60% dosing, right? Let's just stick to 1 valve for now. So I know that I'm 8% dosing. So if I was to start valve 1, I should, there we go. Yeah, see that? It goes right to 8%. Right. So because again, that all ties into your recipe. So in order to get to my set point, my desired, I need 12 liters per cube. Right. I have a two cubes an hour flow rate with a 300 liter an hour channel. So that's where this number comes from. Now, what I see a lot is what I would normally, if a grower is having issues with EC, I'll right away look at this page and see how this is set up, and I'll look at this. So, oh, it stopped already. Okay, well, that's okay. So I will look at the dosing and I will look at this column here. Okay, so what this column here, the EC percent, that's a correction. Okay, so it could be negative or it could be positive. But the more the correction, then the more the P&I control for the EC control is working. It's working harder to try to maintain your set point, right? So usually that tells me that probably this was done incorrectly, right? So maybe it just was, and again, I've seen sometimes where there's a 15 in there or a 20, and then I ask them, okay, well, did you do this test with 150 mils? And they're like, no. Okay, well, how'd you get that number? Well, we just put it in until it started working. So I have seen that happen multiple times. So and it's just by chance, not necessarily by chance or luck, but by the fact that the P&I control internally is pretty good, and so it will make the corrections pretty aggressively to try to figure out, okay, what is my actual dosing percentage to get to my set point. So this column here is just that straight up that calculation from this here without corrections. Then this is with corrections, so it could be negative if we're overshooting our EC, right? So it has to have a negative correction to your EC. If we are below our EC set point, then it'll have a positive correction, so it needs more, right? And so these two numbers are always going to match. This is the summation of those two, right? So it could be we have 8% dosing, but we have a 10% correction. So now our calculated measure is 18%. So we need to be dosing at 18% in order for us to reach our set point. Okay, so that's how that works. And I think that's probably one of the most, I guess, common areas where I see, some struggles if you're having EC issues. It's usually related to that. Hope that's clear. So from there, we can move on from there. Actually, you know what? Let me. I've seen this a couple of times, and just in case some of you out there do it this way. Yeah, let me talk about this because there's been a couple of times where I've seen this happen, and just by chance that I realized what they were doing. The first one is some growers, maybe they're not as conventional, and so they're not using the same ratio. I've seen some growers where they have, like, let's say their A channel, and I don't know the numbers, or I don't know the actual numbers, but it was basically the principle is the same. They said, okay, we did 50 milliliters to 1 gallon, right? And the result of that was like 0.8 EC or something like that. And in their B, they did, like, let's say 70 milliliters to that same 1 gallon. Oops. And maybe that was a 1.2. So then the total is 2 EC. Okay. So I have seen this in a couple of times where they were pre-mixing it before they got our Priva water irrigation management solution. So that's how they were doing it, and they wanted the system to do this for them, which we can totally do it, no problem. It's just you have to know how to convert it. Okay, so maybe some of you out there have seen this, or maybe this might be useful to some, but I'll touch on it real quick, just to help you, those out that might need this. So first we have to take care of that gallon. So we have to turn it into liters, right? Because the irrigation only uses liters and cubic meters. It doesn't use gallons. So we know that 1 gallon is what, like 3.78 liters, right? Roughly. So 3.78 liters times some number X. We need to solve for that with 10 liters of water. Okay, so we need to convert that. So X is equal to, I've done this before, 2.64. So we've turned the gallons here into 10 liters now. But now, now we have to scale that up. So we have to multiply that 50 times 2.64. So that's 132 milliliters. So that's how that conversion goes. So it will be 132 milliliters of A. 70 times 2.64, 180, 185. So that's A. That's B. Okay, so the way that this will be done here is, I don't know if you can do 132 maybe. So 13.2 can do that. Yeah, you can do that. And then, oops. No, we 18.4. So that's how you will set that up. So I know that was kind of an aside, but I've seen this at least twice, 3 times maybe. So because I've seen it a few times, maybe not everybody out there irrigates that same way, especially in the US where it's a lot of growers are using gallons as opposed to liters, right? Okay, hope that's clear. Questions on the dosing? I know that that's a lot of information on these dosing percentages and the correction. I hope that's clear. And again, if you are on the low end of dosing, like let's say 1% or something like that, that's just too low. It's a very low dosing percentage, and it's not the best control. And the other way around, if you're like 99%, there's very little room for control. So you don't want to be in there. You want to be, I would say 20%, 20 to 50% or so. That's good. So it's like balancing a pencil on your finger. If you're balancing on one end, like a 1%, say, imagine that 1%. You're doing this a lot to balance it. Same thing if you're having over here 99%, you're doing this a lot. So you want to balance it somewhere right in the middle. Just an analogy. Okay. All right, so we can move on from there, and then I'll also talk about real quick on these alarms here. So the alarms, so you have your alarms here where you have a too high of EC. So in this case, it's 5 EC, 9 pH, too low, 0 EC, 0 pH. But you also have these alarm set points here. So this is alarm deviation. So 30-second, if you're above or below 0.3 EC after 30 seconds, then it'll alarm. And if you're above or below 4 pH for 30 seconds, it'll alarm. And the 40-second, you're just a monitoring break. So it'll allow the EC and pH control to try to catch up to a set point for 40 seconds. You can make it shorter, but that's just a default value in there. So with these alarm set points here, if your desired is 3.0 EC, but like let's say your high EC is 5, it's going to alarm much sooner than that because your actual alarm deviation here is 0.3. So if you're at, let's say, 3.4 or 2.6 for more than 30 seconds, it will alarm. It'll alarm before it even gets to these high and low set points. Okay, so just something also realize that there's 2 different sort of alarming set points. All right, so let's go to yes, so let's go to our tanks. We'll talk about tanks now, and tanks are pretty simple. There's not too many settings for tanks, but what's important on these is these I4 3.4. So this is if you want to set up where the water comes out of and where it goes to. So this ties in directly to the protection of like if the tank runs low and you want to stop valves, then you want to link this here. So you can say, oh, sorry, okay. So tank number 1 here, recipes 1, 2, and 3 come out of tank 1. Okay, so if any time water system 1 is irrigating out to the field, it's running recipe 1, 2, or 3, it will look at tank 1 settings, and if it falls below these block and stop offtake settings, it will stop it. Water comes out of recycle tank, basically works the same way. So this is the way this is set up is more of a disinfection unit. So the tank number 3 is a recycle tank. So that's like the dirty water tank, like drain. And then here goes to, yeah. So then it goes to tank number 2. So tank number 2 is your treated water tank. So you can imagine that this installation here, we have a UV disinfection system. We got tank 3, which is a dirty tank. Tank 2 is a clean tank. So the software also has an EC pre-control. So you can imagine that we are blending our source water with tank number 2. So tank number 2 is the treated water with some sort of EC content, right? That we can reuse those fertilizers and save some money on fertilizers, right? So now, as far as your tank settings go, you have depending on the installation. So you'll see these lines number 8. We have an option to use a recipe. The way that this tank is set up is it basically looks like a daystock tank, right? So whenever we want to fill it, we want to fill it with recipe 1. So recipe 1, we know it's tied to water system 1. It's going to run water system 1, and it's going to do whatever kind of EC and pH control. So it's going to send water to tank number 1. Okay, that's going to be treated. Sometimes we don't do that. Sometimes it's just a tank that gets filled by like a fill valve, and there's no treatment. It's just a source tank. You know, it's not treated. But the settings are important, are down here. I mean, of course, your fill up settings, right? So this is where you want to start. If it drops below 87%, you want to fill to max. Fill up is just a different set point, so it's a little bit lower. So 12 to 15, that's actually pretty low, but you know, you can put whatever you want in here. But the way that these settings work, block and unblock, and stop off take, they're 2 different settings, okay? So the block and unblock setting is if there are valves that are already started, they're already in the process of irrigating, they will be allowed to continue, right? But any new valves that have not irrigated will be blocked until it gets above the unblock setting of 10%. Okay. Now, if the level continues to drop to 4%, then that will completely stop the water system, and even the valves that are already on, they will stop, and they will not be allowed to be released until they go above the off-take free setting of 5% here. Okay, so two different set points. Okay, the block is if the valves are actively irrigating, they can continue to irrigate unless the tank gets too empty, then they'll stop. But any new valves cannot be turned on until it goes above the unblock of 10%. Okay. And this one is just an absolute safety, no matter what, stop all water offtake, right? As soon as we get to 4%. Another important thing with tanks, now this is only if you have a day stock tank where we're treating water and sending it through the water system, right? Whether it's a pre-one or not, and sending it treated water to a tank. You should put in this capacity. This capacity here is not how much the tank can hold. That's actually this number here. But this capacity is cubic meters per hour. So that's your flow rate. So that's sort of like on a valve installation where you put in the number of emitters. Yeah, the number of emitters to the capacity of each emitter. It's like that, except the tank fill valve doesn't have that number of emitters, right? So now you have to put it in here. Okay, whenever the tank is filling, what is the flow rate? Now, this is important because if you do have the flow monitoring on the water system, it will stop it if it's if the deviation is too much. But either way, most of the time we set up the injection units to work based on the measure flow, not the calculated flow. So on the previous example, I was talking about the 2 liters an hour, or sorry, the 2 cubic meters an hour for valve 1. It is 8% dosing, right? That's the dosing percentage, but that's on the calculated flow. Let's say the measure flow is like 2.2 cubes, 2.3, or 1.8, whatever it is. It's based on the measure flow, not the calculated flow. Okay, that's usually how we set it up. Sometimes we do it based on the calculated flow, but most of the time, at least the way I set them up, I always, well, first of all, I make sure that the flow meter is calibrated correctly, is working right. And then we set it to flow. So we always want to make sure it's injects based on the actual flow rate, right? Not what's calculated. So again, just put in this number here for whatever the flow rate is. But usually your leader or Priva might do it for you as well too. Once during the testing, especially during the testing, because we'll always test to make sure that we're able to fill accurately with your EC and pH set points. Okay. All right, so that's about as much as I want to go for tanks. I want to stick basic because I do want to talk about. Now we're going to talk about valve groups and start strategies. Okay. We'll talk about the substrate start. So that's I500. That's a different type of control. So I'd say most users have this. But we are seeing a lot more substrate users and users who want to irrigate with the scale, right? And so we can use a substrate start program. So that's I500. So the things that we need to first of all consider is our allocation. So let's look at how we do this. So again, this just like with our water systems to main, we like to keep this consistent and easy to understand. So typically you'll see one start program to one group. And we keep it equal, right? So start 1 to group 1, 2 to 2, 3 to 3. Simple, right? Makes it easy. Okay. And then we got to make sure that our valves are allocated to the right valve group. Okay. So we know that group 1 is start 1, right? Group 2 is start 2. Group 3 is actually start number 3. So in our cases here, so valves 1 to 3 are on group 1, 4 is on 2, and 5 is on 3. Then we also have our substrate start strategy, so that's I500. So I500 does not have a valve group page. All that is on I500 sub. We'll touch on that. So for the substrate, you got valve 6 and 7 on substrate 4, and 8 and 9 on substrate 5. Okay, so just a quick overview on the links. Now, the way that these two work is I400, right? So your start strategy, that is going to determine when your valve runs, right? So when it runs, how often, like what are the intervals and all that, under what conditions. Your valve group settings is going to be what it actually does, how long it irrigates, what's the quantity that it irrigates, right? So what recipe it runs, right? So we'll go over some basic information on this. So the way that this particular strategy is set up, you've got 8 different periods, and typically we use the very last period as your nighttime period, right? So that would be because you see this maximum rest time at 24 hours. So once it hits this nighttime period, it basically is going to wait 24 hours to irrigate, so it'll never get there, right? So a typical start strategy is something like this. I mean, of course, but you can have any number of periods on here as well as any number of influences. You'll see here there's start condition, which is moisture level. So we got a start time at 8 o'clock. So 8 o'clock is going to start. It's going to run phase 1, which I'll explain what that is. It's got a certain quantity, which is coming from phase 1, from the valve group. And it's got 2 different things to look at here. So you got a minimum rest time and you got a maximum rest time. Okay. The difference is the minimum rest time is a protection for irrigating too often. And the max rest time is sort of protection for not irrigating enough, right? So a max of 2, let's say in this case, every 2 hours you want to irrigate no matter what. So the way that the minimum rest time works, it's only valid really if you have some condition to start. So in this case, we have moisture level 60%. So I'll go to this installation page here. You've got a whole number of things you can use. You can use external temperature start, humidity, radiation, right? So you have all these conditions that you can start with, right? And you can set a certain number of conditions you want to be true before you can start. You can definitely overcomplicate this for sure, or you can use just max rest time. Totally, it's for everybody has their own, their own way they want to do it. But let's just assume that right now we're just going to start based on moisture level. Okay, just one condition. Right, so we want one condition to be true for this period, for the morning period before we irrigate. So that moisture level is 60%. So if the moisture level drops below 60%, we want to irrigate, right? But we don't want to irrigate too much. So, oops. So this minimum rest time here, That's what that is. So at 8 o'clock, basically this is going to run right at 8 o'clock because of the max rest time. Really, it's going to run because of the max rest time. If you could take this off and have it not irrigate on max rest time, and it's going to wait until it hits that 60% or lower, right? So you could do that, but the max rest time will be, hey, right away at 8 o'clock, go ahead and irrigate, and you're going to wait at least 2 hours. Now, it's going to wait at least 1 hour minimum, even if you drop below 60%. Okay, so let's say you irrigate, the moisture level goes up to 80, 85%, whatever it is. The moisture level starts to drop below the 60% set point. If it's before 1 hour, it will not irrigate because it's waiting that minimum rest time of 1 hour. Okay, after the hour, if you're below that 60%, then it's going to irrigate. Okay. Or you can make it, let's say, for example, every 30 minutes. So you got to wait every 30 minutes before you're allowed to irrigate. So again, this is just a protection to irrigate too often. And this is more of a protection to not irrigate enough, essentially. You don't have to have a max rest time. You can irrigate on only conditions, whether it be a radiation start, radiation sum, moisture level, you name it. Any of these here. Okay. And you can switch this off, this max rest time. You don't need it, but I would say most growers at least that I help have max rest time just because they want to irrigate at least, even if maybe the conditions outside aren't necessarily there for it to, maybe it's gloomy, cold, or rainy or something, they still want to irrigate. So no problem there. Hope that makes sense. Now, phase one, so that comes from your valve group settings here. So that's valve group 401 here. So when phase one runs, it's going to do this here. So what is phase one? That is going to irrigate for either 1 minute or 100 milliliters. Again, this is whatever comes first, right? It's going to run a recipe 1, and it's only going to run it once. The number of times phase, that's if you wanted to repeat it consecutively. So like it could be, let's say it goes to valve 1 and 2 first. Then it goes to valve 3 and 4, for example, and then it comes. If I put a 2 in here, then it comes right back to valve 1 and 2. So that's if you, let's say, didn't want to introduce all that volume of water in one shot. You want to kind of pulse it in a sense. So that's what that is. So you'll do it once for a minute, and then do the other valves, and then come back around and do the same valves again over. So that's if you have that number of phase here. Okay, now I mentioned earlier this here, the quantity and time. The valve will start from either these settings here or these settings here. Okay, so if I have this use quantity and time set to yes, set to yes, then it's going to do whatever's in here, right? Now, if I change this to no, you see those lines disappear. Recipe, that disappears. So now there is no phase groups, no phase settings, right? So now what is it going to default to? Well, it's going to default to this here. So it's going to irrigate 150 milliliters per unit, or 30 seconds, again, whichever comes first, recipe 1. Okay. So I would say typically I don't see it done that way. Typically I see it done this way, where you have a set, different phases that you run for your start strategy. Yeah, makes sense, hopefully. And now once we get into our noon period, or so at 12 o'clock, it's going to run phase 2. Phase 2 is 2 minutes, 200 mils, so double the quantity, double the time. And it's actually running a different recipe. So in this case, recipe 2. Oftentimes I see it's always the same recipe, but yeah, you definitely can change your recipe as long as, again, the recipe is tied to the same water system, right? The correct water system. Now, if you do something like this, like phase 1, 2, it's going to run phase 1, 2, and then right after that, phase 1, and then right after that, phase 2. I don't see anybody using this, but you can if you wanted to run one thing and then immediately after that another. Which I can see that maybe one is like something with EC, and maybe recipe 2 is like no dosage, right? So maybe it's the fine rate irrigation, and you want to have whatever's in those lines just no dosage, just water with no EC, maybe. But that's what that does. It'll run 1 and then 2. But again, typically we don't see that. So you see something like this. Now, the difference between these two is period 2. There is no other condition that we've released here. the start. So basically, it's just going to be on a 1 hour max rest time. So every hour it's going to irrigate until it gets to your nighttime period. And once it hits your nighttime period, it'll stop all irrigations. Okay. And let's talk about I-500. So I-500, it's a little bit different. There is no, like I mentioned, there's no valve groups. So the I-500, you have to make sure that we have to look at the I-500.4 page, okay? And the reason for that is we've got to make sure that we have the valves tied to it, right? So number one is make sure that the valves are tied to it, but also we have to make sure that the scale moisture measurement or is tied to that valve group. Otherwise, you won't have the data. So in this case, so substrate 4 is the only one that has a link to moisture measurement number 3. Okay, so that's drain tray number 3. If I was to try to run substrate number 5, it would have no data as far as any kind of weight on the scale, drain. It wouldn't have any of that because nothing's linked to it. So that's number one. Secondly, is you can turn on the number of periods. So I think 6. Yeah, so you can have up to 6 periods as opposed to 8 on a standard I-400. So the way that this looks is you've got a couple of different options here. You can irrigate based on weigh scale, a moisture measurement, so moisture sensor, basic, which is just time, and then weigh scale step. So that's a different kind of step control for your irrigation. If you're only, I guess if you're not intending on using the scale at all, then and you're going to just stick to basic, it's almost why have I-500, right? Why have the substrate strategies? You may as well just have the valve groups if you're only going to irrigate based on time. Okay. So you notice you don't have a valve group setting where you can put in different quantities and recipes and all that is built in right into the I-500 page. Okay. So you've got, again, we only have one. Your period number 6 is always night period in this case for this for the I-500 substrate. So you got your quantities, time, recipes, minimum rest time. So a lot of the same thing that we saw, and then you can have different start conditions. So on here you have to actually link it. So if you click on this here, you can have let's say humidity measurement, maybe a radiation sensor inside the greenhouse or something like that. So you can link other influences to as a starting condition for it. But typically, actually, you see this down here, the transpiration. So it's measuring transpiration, even though this is just a simulated environment. So because it's linked to the moisture measurement of 3, that's why you got a number in there. If it was not, in fact, if I go here to 5, it shouldn't have anything in there. Even if I also try to turn it on, probably won't even. Yeah, actually, it's not. It won't even let me. It's not even linked. So you won't even get the options if you don't link the scale. Okay, so let's go back to here. Now,
Jose,
yeah,
there was a question here. Fabian was asking, does the up and down arrow on the start time represent AM and PM?
yeah. So this, if you have the up arrow, the time will adjust automatically for you based on the sunup times, and then the nighttime, if you have the down arrow, the times will adjust for you based on sundown times. Yeah. But if you want it to a fixed time, right, so it doesn't adjust those times for you, then you could just leave the dash. But yeah, so the up arrow is sun up times, down arrow is sunset times. Yeah. Okay, so let's change this to, let's say, scale. And then we're going to get other options. Okay, so now this is going to be where you will have to, I would recommend, if you're going to be using an irrigation weigh scale, is to first be comfortable with the measurement of the scale, be comfortable with the maintenance of it. So you have a drain sensor that needs to be maintained often. If it doesn't, the drain tipping spoon can fail, and that will cause you to not collect drain, miss irrigation, things like that. So you always have to make sure that the drain is the scale installation is not, there's nothing getting in the way or causing bad measurements from the scales moving or something being put on top of it. You have to clean out the drain sensors often, right? Get all that plant material out of there, rinse it down because you get buildup of salt, especially the buildup of salts on the tipping spoon, and they will actually get stuck. So the tipping spoon will get stuck, and you'll get an alarm that says the tipping spoon is stuck, basically. And yeah, you might miss irrigations, and you'll just have bad data. So if you're irrigating based on a wave scale, there's a lot of different settings that we have. Now, this is something that we're probably planning on talking about in a future training, because there's a lot to unpack here. If you're irrigating with a scale, there's a lot of information to unpack, because there's different types of irrigate. There's different types of collecting drain. So that's a lot of information for each one of these two. But basically, the idea is you want to achieve some sort of transpiration, which transpiration is a loss in weight, right? So as the plant transpires, the weight of your scale goes down because you're losing it to evaporation, right? So the units, I believe, is milliliters per unit per hour. Yes, mils per unit per hour. So basically, however many units you have on there. That's another thing too. Is when we do the installation for those, we have to tell it like what's on the scale, right? How many emitters are on the scale, so we know what the increase in weight should be when we irrigate based on a certain quantity. So you got a minimum transpiration before it can start. So this number here is one of those other ones where I would on something like this where you're measuring the transpiration to store the data and see the trend. So you might have to see the trend for a couple of weeks or something to see how the crop is behaving, how the transpiration, what's happening, and then that'll give you a baseline of, okay, I want to irrigate when my crop is transpiring of, let's say, a number that I have actually seen use is I think this was strawberries. Yes, it was strawberries. 120 milliliters per unit per hour. So when the transpiration was greater than that, so the crop started to transpire, then that's when, okay, the crop is awake, it's active, right? And so we can go ahead and we can start an irrigation. Your morning period, so is your moisture increase rate. That's how much weight you want to increase before you hit before you start getting drained. So normally you don't want it to be too much. So like I have seen this where it was like 1 liter, right? So you want an increase rate of 1 kilogram of weight per hour. And so that just really aggressive irrigations right away, and you start to get drained really early on. So that might be too much, right? So you're going to get, after just 1 or 2 irrigations, and you're already getting drained. So that might be too much. And again, just depends on maybe your crop, the type of installation. So another thing to probably toy around with and see, okay, maybe half a kilo an hour is what you want it to target, right? That's a moisture increase rate, weight increase rate that you want. And then you have your maximum dry out. So this is safety level. So these settings are kind of, and even the weight and everything displayed in here is not necessarily correct because it's a demo, but this is a maximum safety. So if we lose a certain amount of weight, it'll trigger an irrigation, even if the transpiration is not there, or even overnight. Like if you have a situation overnight where for whatever reason the crop loses weight. I know like the Santa Ana winds over on our side in California, so it happens to where at night, typically you would not see that the crop is active, but then we do see transpiration go increase, and we see the weight go down from evaporation, and we can irrigate basically as a safety. Okay. And
Jose, we were wondering, obviously this is the Priva grow scale, but could there be a way to integrate, they're asking about a Groden sensor with Priva?
yeah, I've seen some Groden sensors. I don't think I've seen, now those are moisture sensors, the ones that I've seen. I haven't seen any scale. So this is specifically to a weight platform with a drain sensor. But yes, so there are some Groden sensors that I've worked with. Those are just moisture sensors that will give us, let's say, a percentage of 0 to 100% moisture rate, and that would be using the moisture measurement here. Now, the thing to keep in mind on those sensors is some of the Grodan sensors. Actually, I don't know if well, okay. So some of the new ones that I've seen, the communication protocol is SDI-12, and so what that means is that you need to have a special converter so that we can pick up that signal to Priva. Okay, because for us to use a sensor, it needs to be a standard universal, like a 0 to 5 volt output signal or 4 to 20 milliamp signal. So those are like universal sensors, and we can calibrate those a certain way. But if it's a communication protocol, like a lot of grow dance sensors I've seen, they're SDI12, that there has to be a special converter. Now, if the Grodan, I have seen Grodan, they do sell them. It might depend on the model, but they do have their own SDI12 converters, which you wire the sensor to those converters. Then from those converters, it changes the SDI12 to a standard 0 to 5 volt signal, and then we can pick it up. But if they do not have an SDI12 converter, then you will need to have SDI12 converters directly from us. So we have equipment, so it will be an equipment cost and software to do the conversion from SDI12 to a standard one. It is, but yes, it is possible.
Thank you.
Yeah, no problem. Oh yes, the other last thing I want to touch on this, because again, we might do maybe a more in-depth one about this, because this is a lot to unpack. Is the saturation weight. So manual is if you put in your own weight of when it's of what the crop is when it's completely saturated, right? When it can no longer hold any water, it's all going to go to drain. But ideally, you want it to set it to automatic. What that does is every day, the new weight is calculated based on drain. So if as we're ramping it up in the morning to get your saturation weight point, once we record drain, we say, okay, now we look at the weight, whatever that weight is. We say, okay, that's our new weight. So now that's the weight that we can no longer hold in your water. So that's our target for the next day. And as your crop keeps growing, then the saturation weight will be updated every single day. So it's going to start to increase and increase and increase. So definitely leave this to automatic. However, again, maintenance is extremely important on this. If you're going to be using irrigation with a scale, you really have to make sure that that you regularly maintain it. It works really well. I've seen some great results on a couple of different projects. The reason why a few of them stopped working was basically because of maintenance. The tipping spoon failed, and then the sensor started to fail because it was not maintained, and so they've started to have bad data misvariations and things. So just keep that in mind, that if you're going to be doing this, it's the settings are important, great, right? Measurements are great, but if you don't maintain the sensors and the installation, yeah, you're gonna have a harder time for sure.
And Jose,
Yep.
can you block an irrigation shot with using this, such as a minimum rest time, but with dry out percent or slab weight?
Block irrigation. No, because I mean, I don't think so. Or maybe I'm just not understanding, but not necessarily, because I mean, it's not going to that. As you can see here, there is not. I mean, you can actually turn on the max rest time, but the max rest time by default is not even on, because normally on a scale platform, and if you're only irrigating on transpiration, you're not waiting for max rest time, right? It just depends on the outside conditions that determine when the crop transpires. But I would say no, there's not really a way to blocking it. I mean, if the conditions are met for transpiration, so the crop is transpiring, it's awake, it's active, then it's going to trigger an irrigation.
Okay.
Yeah, I'm sorry if that wasn't a good explanation, but yeah, I think that's actually it. That's the end of the subjects I wanted to talk about. Actually, yes. Okay, so yeah, I think we can open it up to Q&A. Or any additional comments or concerns anybody might have. Feel free to chime in or put in the chat box.
Yeah, any questions that didn't get answered, please feel free to speak up. I think we tried to keep up on the chat, but if there's anything that slipped through, please feel free to bring it up and we can have a discussion about it. Jose, I had a question. Is there a way to monitor how much water and fertilizer you're using?
Yeah, so it's a general overview already. Let's see, it's under You can go to water. You can look at your overview irrigation today, your water use, overview consumption today or term. You can also, yeah, overview. There's also, oh, sorry, reporting. So if you go to your water report, actually, I don't even know if this will have anything because it's a simulator, but you can, yeah, it's no data. But yes, you can do that. You can generate reports for that. Yeah.
Thank you. We have another question here. Is there a way to scale back the desired EC of a tank filling with a recipe through a water station?
Scale back desired EC. So I would say, so the only way, and I didn't actually really mention this, but you can adjust your EC set point based on radiation. So you can have a start and end radiation set point. So the higher the radiation, maybe the lower the EC set point. Somebody gave me an analogy once of like, they say, hey, like, you know, when it's really hot outside and you're really thirsty, what do you want? Do you want a soda or do you want water? So I'm like, oh, yeah, give me a water just to, you know, I'm thirsty. I don't want a soda. So he said basically crop might be the same thing. So as radiation goes up, maybe you want your actual EC to go down. Maybe they want more water as opposed to more EC. So that's definitely an option with our radiation. So you can have a maximum amount that you can decrease. So like, let's say 0.5. So it'll take off 0.5 EC as radiation goes up from 0 to 100 watts per square meter, or whatever you want, 500, 600 watts per square meter, whatever you think is a good number to reach for. But that's the only way to really change the outcome of your EC target right here. I hope that answered that question, or maybe
I think that was sufficient. Yes, that was
oh,
perfect.
if you're using, oh, you're talking about EC pre-control, yeah. So the EC pre-control, if you have this on, so if you're using, you still need to give this information. It's just going to factor this in. So now, if I have this on, if I have this on, then I know that what's coming is going to be 1 EC. So it's going to make up the difference from 1 to 2. It works the same way as, like, for example, not every, like, let's say you didn't have EC pre-control at all anyway, but your nutrient recipe, like if you have RO, for example, then it's, you know, 0 EC. But if you have maybe well water or some other source of water that does have some sort of EC, then you put that number in here, and it'll take that into the calculation for it, and it'll basically to have your injectors just make up that difference. That's why, for example, this has happened a couple times to me where just by accident somebody put in, like, let's say 4, or just totally on accident. Maybe they meant to put in the too high EC alarm, but they put a 4 in here. Look what happens there. It goes to 0 because it's like, all right, well, my incoming water from my source is 4 EC. I don't need to inject anything, right? So it's just my dosing channels are not going to work. Right. So yeah,
But if you're reusing fertilizer water, right, then it's constantly changing throughout the day. So how does the EC supply accommodate that? Because it's gonna, you know, in the morning there might be no recirc, so then it's gonna be 1. But then in the afternoon, when you're using fertilizer recirc, then it's gonna be like 3 that's going in or something.
Well, yeah, so that's why it only works with blending it with a source of low EC. So the EC pre-control only works with a blending valve with a low EC and a high EC. So basically the way it works is when we open the mixing valve, we expect the EC measurement to go up, right?
Right.
So if we close the mixing valve, we expect it to go down. That means we're getting less water from the treated tank with a high EC and more water from your non-treated tank. Right. If we don't have that, so if all we get is that 3 EC coming in, then at that point you don't have any more control. The 3 EC coming in is going to be, then this is going to go to 0 because it doesn't need it. But now what happens in that case, like let's say it's 4 EC, right? So then you really don't want that. You want your installation to be able to blend, you know, if, even completely close it off if needed to only use RO versus treated. Because yeah, you're right. You don't know exactly what's in it because it's always fluctuating as you
Yes.
collect drain and as you, yeah. So your installation really does need to be able to have a proper blend of your RO or low EC water to your treated water tank, because your mixing valve is gonna trap. Now, if you have a desire of one, and your mixing valve is you know, measuring, let's say 3 EC, right? Because that's what the EC sensor upstream of your water system is measuring. It's going to try and close the mixing valve to get to that 1 EC. But if it's still measuring 3, it will alarm. It'll say EC supply defective, and it'll stop the water system. So you have to have a way of blending a low EC. Yeah.
Right. That makes sense. Thank you.
Yeah. No problem. Mhm.
So other questions here, Jose, asking about water usage and consumption over a specific period of time, changes in consumption of water.
Sorry, say again.
This question
I
here
see?
is asking if you can see the water usage or consumption, if it went up or down during a specific time period
So
using the
that's,
reports.
yeah, no. So unfortunately, with the reporting, there's nothing in there that is going to have anything related to time, unfortunately. It's something that I actually have asked before to like our R&D guys. This has been a long time ago, probably a few years now. And basically, the answer to me was that, you know, the important thing is the total quantity that was delivered to a valve, and so time is like a lot of growers, they just irrigate based on time, and they want to know, okay, how long was my valve one open? Well, there's nowhere where that's stored. The only way to know that is to actually, like, let's say, store the format, store this status, I guess, of when it's actually active. But then you have to look at your graphs, and then you have to like export. Well, first of all, even if you export the graph, there's only 5-minute intervals that you get the data from. So let's say your valve only had like a 3-minute runtime, you may be missing that gap of data, or you may only have partial data for that because it's 5-minute intervals. So the reporting is only really going to give you like a total of like how much was used per, like, let's say a day or per period, right? So if you're looking at our, now this doesn't have it because it's just a simulator, but if you're looking at overviews, you could choose like monthly, quarterly, weekly, yearly. It's just going to give you the total for that period, but it won't tell you like during these times your consumption was greater or lower. There's nothing related to like time anywhere in reporting.
Can you do a report for OIC, because the term that I have only shows me 1 or 2 days?
Sorry, can you say again?
Can you do that for me? Because I tried to do the report and only shows me the past 5 days.
I don't think so, just because there's nothing actually in here. If I go to reports, like, but again, it's just because this is a demo. Oh yeah, there's nothing on here. Is this what you mean? So you can choose period, week, period, quarter, year?
Now I see water reports. Got it. Thank you.
Yep, no problem.
Thank you.
So there's actually some data on here, even though it's a simulator. I saw another question here. The dosing channel, does the dosing ratio dictate how long the dosing valves from A to B stay open? No, they there's dealer settings where we put in a number. So there's a cycle time, so it pulses, and then there's a cycle time of where it looks at the EC measurement, and then it pulses again for again if it needs to, and there's a maximum pulse length. So you might see that your pulses start to increase and decrease, right? So initially, I think we set it to like the minimum pulse is like for the first pulse is like, I think like a half a second or 0.4 seconds or something like that, but it might stretch out a little bit longer than that. But if you ever hit 100% dosing, for example, which that would mean that, well, that would mean there's no control anymore. So we just have the valve wide open. Then it just holds the solenoid open, and it's 100% open. Unless you have a frequency pump, then we pulse it really fast to get that frequency pump to inject more and more and more. So, but there's no, you can't really control that yourself, I guess. It's a dealer setting that we put in for that cycle time of that. It gets a cycle of like an EC measurement to make the next decision on if it needs to inject more or not. But those are all dealer settings, not something you have control over.
And Jose, one more here. In the tank installation settings, does that capacity for filling have any effect if you do not have protection on?
No, it doesn't. It doesn't. So I guess it would if we're injecting based on the calculated flow, but like I mentioned, we usually don't. We usually set them up to where we're injecting based on the measured flow. So if we have a flow sensor and it's actively filling into a tank, even if you leave it at 36 cubic meters, that shouldn't matter because we should be injecting on the measured flow. Now, if we're not, if we're injecting on a calculated flow, then that's when you might run into some issues. However, like I mentioned, the P&I control is pretty good, so it will make a good job of applying those corrections on M420 and adjusting the dosage percentage. The problem is if you have small tanks. So like there's some installations where like we have a small tank, it takes a couple of minutes to fill, and you don't have a couple of minutes to wait until it more or less finds reach the set point. So you need to make sure that it gets right up to that set point as quickly as possible. So that's where, yeah, you want to make sure that the titration is done correctly, and you want to make sure that you try to tell the system like how much the flow rate it is. But it won't actually affect it if you don't change it from 30, because the default value is 36 Qs. But like I said, unless we're injecting based on the calculated flow, shouldn't matter because we're always injecting based on measured flow. Like I would say 9 times out of 10. Sometimes I see we don't, but most of the time we are.
Okay. Any other questions out there at this moment? You know, we're also looking for suggestions for upcoming topics for the next live training. So we'd love to hear some suggestions if you have any suggestions in general or comments about the training session. Feel free to punch those into the chat and we'll review all those at the end to make sure that we're all kind of getting the most out of this. So if there's no other questions, I think, Jose, did you want to add anything else here before we finish?
No, just to thank you for being here and for participating, and I hope you guys got something out of it. So yeah, hope you guys hope it was good for you guys.